Ever wondered how an ant, so tiny, can carry objects many times its own weight? Well, you're about to find out. Ants, as small as they are, exhibit an incredible display of strength that leaves us in awe. How can such a minuscule creature perform such Herculean feats? The answer lies in the strength-to-weight ratio of these fascinating insects. The strength-to-weight ratio of an ant is vastly superior to that of larger creatures, including us humans. This means that an ant can carry loads much heavier than its own body weight. To put it into perspective, it's like an average human lifting 2 elephants. Now that's strength. But what gives ants this extraordinary strength? The secret lies in their exoskeleton structure. Unlike us humans who have our skeletons on the inside, ants have theirs on the outside. This exoskeleton is made of a material that is both light and strong, allowing ants to handle heavy weights without their bodies being crushed under the load. But the strength of an ant isn't just theoretical, it's been observed in the real world. Some ants have been seen carrying leaves, seeds, and even insects that are several times their own weight. The record holder, the leafcutter ant, can carry items up to 50 times its own body weight. That's the equivalent of a human lifting a truck. In contrast, the strongest man in the world can lift just over 5 times his body weight. That's impressive, no doubt, but it pales in comparison to the strength of an ant. This comparison isn't to belittle human strength, but rather to highlight the extraordinary capabilities of these tiny creatures. So next time you see an ant effortlessly carrying a crumb that seems way too large for it, remember the strength-to-weight ratio, the exoskeleton, and the Herculean strength of this tiny creature. Yes, ants are indeed tiny powerhouses, effortlessly outperforming even the strongest humans. But what's the science behind this incredible strength? How does something so small possess such power? Well, let's dive into the fascinating world of ant biology to find out. Firstly, we need to understand that ants, like all insects, have their muscles on the inside of their exoskeletons. This is the exact opposite of humans, who have their muscles on the outside of their skeletons. Now, this might seem like a minor difference, but it's actually a game changer. It allows ants to use their muscles more efficiently, giving them the power to lift and carry objects many times their own weight. But it's not just about muscle. The structure of an ant's body plays a key role too. Ants have long, slender bodies that are segmented into 3 parts: the head, the thorax, and the abdomen. Each segment is connected by a tiny, flexible waist that allows the ant to twist and turn its body in all sorts of angles. This flexibility, combined with their jointed legs, gives ants the ability to leverage their strength and move heavy loads with ease. Now you might be wondering, why does size matter? Well, in the world of ants, smaller is actually better. Ants are subject to what's known as the square-cube law. Essentially, as a shape grows in size, its volume grows faster than its surface area. In layman's terms, this means that smaller creatures, like ants, have more muscle relative to their body weight than larger creatures. This allows ants to exert more force and carry heavier loads relative to their size. So, in the grand scheme of things, an ant's strength isn't just about being strong. It's about being smart, efficient, and adaptable. It's about leveraging their small size, their flexible body structure, and their internal muscle arrangement to their advantage. In essence, the strength of ants is a marvelous example of how nature optimizes for survival. Ants are not only individually strong, but their collective strength is a spectacle in itself. Dive into the world of ants and you'll witness a fascinating display of teamwork. Each ant, though small, contributes to the grand scheme of things, making them a force to be reckoned with when they work together. They can carry objects many times their own weight, but when they combine their efforts, they become capable of moving loads that would seem impossible for such tiny creatures. Take, for instance, the way they construct their colonies. Each ant plays its part, carrying grains of sand or pieces of leaves, and together they build intricate structures that can house millions of their kin. It's a feat of engineering that would make any architect green with envy. And when it comes to protecting their queen, the heart and soul of the colony ants band together in a remarkable show of solidarity. They form protective barriers with their bodies, fight off invaders, and even sacrifice themselves if needed. It's a testament to their collective strength and dedication. But perhaps what's most impressive is how these collective efforts lead to incredible feats of strength. Imagine a group of ants working in unison to lift a fallen twig or haul a dead insect back to their nest. It's a sight that truly showcases the power of teamwork. In the world of ants, teamwork truly makes the dream work. What can we learn from ants, and how can we apply it? Well, ants are tiny, but they're also mighty, and their strength and behavior have the potential to significantly influence human technology and systems. The field of biomimicry, for instance, is an approach to innovation that seeks sustainable solutions to human challenges by emulating nature's time-tested patterns and strategies. Imagine, just as ants carry many times their body weight, we could design machines and robots with similar capabilities. The robotics industry is indeed learning from the humble ant. By studying their movements and strength, engineers are developing robots that can lift heavy objects and move with the agility of ants. But it's not just about physical strength. Ants are also known for their remarkable cooperative behavior. This is something we can apply to our societal structures, from traffic systems to crowd management. Ants follow strict paths and adhere to an efficient system where everyone knows their role. If we were to mimic this, we could potentially create more organized, efficient, and less chaotic human systems. Moreover, ants are masters of construction. They build complex colonies with intricate pathways, ventilation systems, and nurseries. This architectural brilliance of ants can inspire us to design more efficient, sustainable, and resilient human infrastructures. Indeed, ants are not just insects. They are living lessons of strength, efficiency, and cooperation. So, we've learned how ants, despite their tiny size, are powerhouses of strength. Their impressive strength-to-weight ratio, the fascinating science behind their might, their collective teamwork, and the potential applications for us humans. Next time you see an ant, remember, it's not just an insect, it's a testament to nature's strength and ingenuity.